This call is now being recorded.
Alright, so we start our class now. Okay, so actually this one is a continuation from the previous, right? Previous 3.1 exercise. Okay, so I already discussed about this one. Okay, how okay, so like this is the example, like how do you put, let's say, for the candle flame, right? What happened to the candle flame? Okay, when you put in the electric field. Okay, so you have two plate here, positive and the negative, right? So the negative will attract the positive part, while the positive will attract the negative part. So you can see at the positive plate here, right? It's much bigger. The flame is much bigger than the negative one. So this is why, because of the size of the positive charge is much bigger than the negative charge, right? So let's try to answer these questions. Um, Okay, so I want you to try to answer this one. Okay, for number 5. So it says here the diagram 8 shows the shape of the flame. Okay, for the candle flame. Okay, when the candle is placed between two plates, okay, X and Y, okay, that are connected to the VLT, to the VLT, right? So what is the charge, okay, for the X plate and the Y plate? So you need to know that the bigger flame, it has the what charge, right? Means at this side. This side has a bigger flame, right? So what charge is that? And this one is what charge? So then you can know what is the X charge and also what is the Y charge. Because the opposite charge, they will attract each other. Okay, I give you like 2 minutes. Okay, then I will stop. Then we will discuss. Okay. All right. So here, right? So you can see this at this side, right? The flame is much bigger. Okay, so compared to the right side here. So this one must be the positive charge. Okay. So this one must be the negative charge. So of course the X plate, okay, must be the opposite charge because it need to attract, right, the charge. So this one should be negative, okay, and this one should be positive. Okay, so the answer is X is negative, Y is a positive. So the answer is D. Okay, very good. Okay, the next part is this one. Alright, so you need to answer diagram 8.1 shows a metal coated polystyrene ball hang between two metal plates. Okay, so the metals are connected to an extra high tension supply. So a strong electric field between metal plates R and S is produced when the switch is on. Okay, so we just discussed this one I think like 2 weeks ago. Okay, so let's say if I push, right, if I pull the polystyrene ball, okay, to the positive plate, okay, so what will happen here, the positive charge will be transferred to the polystyrene ball here. Okay, so now it become a positive charge. Okay, then the positive charge, you know already, positive that will repel, right? So it will push the polystyrene ball to the other side here. Okay, then here the negative charge, right? The negative charge will be transferred to the polystyrene ball here. So now it become a negative charge. So negative and negative will be repelled also. So it will push the polystyrene ball back to the positive plate. Okay, so again at the positive plate, the positive charge will be transferred to the polystyrene ball. Now the polystyrene ball has a positive charge, so positive plate with the positive charge of polystyrene ball that will repel. So it will push back to the negative plate, right? So this one can it will be like the continuous, right? So means it will be the polystyrene ball will be swing, right, continuously. Okay. So the first question they ask you, what does it mean by the electric field? Okay. So try to answer this one. It's on your notes, I think. When they ask you about the field, like electric field, so when they start with electric field means they must have the word region, a region which what experience what. Okay, and also for B also you need to answer. So it says here when the metal coated polystyrene ball oscillate between two plates for 3 minutes, okay, with the current 0.3 ampere, so calculate the total charge. So this one, what formula that you can use to find the total charge here? So the total charge usually the unit is in coulomb, right? So which formula? Okay, they use a coulomb as a unit. Okay, I give you 3 minutes to answer, then I will stop. Sorry. Okay, 30 seconds more. Hmm. Okay, let's discuss. Okay, so what does it mean by the electric field? So a region, okay, where an electric field or sorry, electric charge experience a electric force. Okay, so if you put the electric charge, okay, on that region, you the electric charge will experience the electric force. Okay, the electric charge experience the electric force, so that we call it as the electric fields. Okay, for B we use the formula Q is equals to IT. Okay, so your T should be in seconds, so you have to change it to second by 3 times 60. Okay, so Q is equals to IT. So your I is 0.3, your time is 3 times 60, so you get 180. So the answer is 54 coulomb. Right, so let's check. Right, very good. 12.1.67. This one you use what formula, Ching Yang? Hmm. Okay, so the next one, they ask you the frequency of the oscillation of the metal coated polystyrene ball can be increased by using one of the method listed in table 8.1. Okay, so this one you need to choose. This one usually come up for question number 8. Okay, the structure part, paper 2, structure question number 8. Okay, so number 8 usually they will ask you to choose. Okay, which method, right? So this one is actually like the question number 9 or number 10, the essay part, right? The one that you need to choose. I choose what, because of what, then you need to copy down the characteristic, right? So this one is almost like that, right? You need to choose and you need to give a reason. Okay, and the end of it, you have to choose which method is very suitable for this. Okay, so this one I want you to try to answer. Okay, so you need to know what is actually the purpose of it. So the purpose of it to make sure that the frequency can be increased. Frequency of oscillation mean it can the frequency, okay, the swing, okay, the swing, okay, it will be increased. Okay, the number of oscillation will be increased. So how you want to increase, okay, the number of oscillation per second. Okay, so try to answer this one. And for the exam, I will go until 3.1, yeah, until here. Okay, for the mid-year exam, then you already know it will already be postponed uh, on August. Okay, it will postpone on August. The timetable will be come out. Okay, soon. Okay, so it's not on July, it's on August. So how about the diameter? Okay, between the two plates. Okay, and the reason why. Okay, and the mass. They say you don't know let's say you give the wrong characteristic. Let's say for the diameter, you choose the answer medium, but the answer actually is long, right? But the reason that you give is correct. You can still get the mark for the reason, although your first choice is wrong, but your reason is correct. Then you can still get the mark for it. Yeah, I give you like 3-4 minutes to answer. Okay, 50 second more. Okay, 5 seconds. Okay, so the first one is the diameter or the distance between the two plates, right? So it should be short distance, okay? So it will be faster, okay? So it will oscillate in the short time or it will be oscillate faster. And the mass of the metal coated polystyrene ball should be low mass. All right. So this one is to increase the acceleration. Okay, you can use the Newton's second law. F is equals to ma, right? So A is equals to F over m. So when your mass is lower, your acceleration will be higher. Okay. All right. So the next part is okay. Wait, I long to increase the frequency. No, low swing faster. Okay, because it's actually should be connected with the acceleration, right? High, strong, and it's very short. More acceleration can be made due to shorter distance. Okay. Low, small inertia. Small inertia. Inertia. Small inertia. What does it mean by inertia? The tendency of an object to move, okay, or to be in the stationary, right? Hmm. I don't think so for this one. Short, low, short, reduce the time of oscillation. So you need to like I said just now, right? Because it said they ask you to find means the frequency. You need to increase the frequency. So me frequency means you need to increase the number of oscillation there per second. So me you need to move faster. So whenever you already know, okay, this one you need to make the bursting ball to move faster. So if you want to move it faster, all the answers should be connected, right, to the purpose. Right. This one is to make the faster. So everything that you choose, I say this now, low mass, so to increase the acceleration, to increase the velocity. So that is when we touch uh the the motion of the object, right? So make sure you know what is actually the question one. Okay. Reduce the time of oscillation. Reduce the time of oscillation. Time oscillation F is equal time or period. Okay, period of oscillation is F is equals to 1 over T, right? So period, okay, but this one you cannot use the word time. It should be period. Okay, low allows the ions to fill the ball faster. No, that's why I said it should be connected. Okay, faster, move faster. So what you need to do? Low mass because you can increase the acceleration. So when the acceleration increase, then it will move faster. Okay. Needs to cover a short distance. Not so. Okay. Diameter between two plate, mass of the will be slight. Okay. Short, high voltage. Low mass, easy to oscillate. Mm, easy to oscillate. Not so. Short high voltage, no. The voltage, the distance is not, like it doesn't connected with the voltage. The voltage is actually connected. What is the amount of voltage that we supply? Okay, it doesn't matter whether the distance between the two plates is big or is far or is close to each other, right? The one that influence the voltage is actually the amount of voltage that we applied. Okay, it doesn't need to be the distance. Doesn't. Or this one you already see the question, is it? Okay. So for this one, the last one you need to choose which one, right? So actually based from the two characteristic we choose before, we already know lah which one we need to choose. So find the keyword here. Okay. Frequency of oscillation can be increased. Frequency means the number of oscillation per second. So means the oscillation you have how you to make it become the number of oscillation increase. So mean it has to move faster, right? In 1 second it has to move faster. So you have to move faster mean you need to choose the one that mean increase the speed, increase the acceleration. Okay. Yeah, I give you like 3 minutes only because it's only two questions and you can already know what question that you need to choose, right? Okay. Okay, so the voltage of the EHT supply, okay, so the voltage should be high, okay, it should be high, okay, because to form the strong electric field, okay, so to form a strong electric field, so this one, of course, the one you need to choose is Z, okay, this one no need to copy back all the characteristic, just put the answer Z, okay, but they say for the essay, question number 9 and number 10, yes, you need to put Z because you copy back all the characteristics. Okay. Okay, very good. Okay, now it says, right, the nylon thread in diagram 8.1 is replaced with the copper thread. So what happened to the motion of the metal coated polystyrene board? Okay, the first one they use nylon and they replace it with the copper. So give the answer give a reason for your answer in E1. What happened to the motion of the metal coated polystyrene board? Is it the acceleration will be increased, the velocity will be increased, or it becomes slower, or it will not move, right? So when it happens to the motion, only you can describe increase acceleration, if the velocity increase, it's stationary, okay, the velocity decrease, acceleration decrease, okay. So that is for the motion. And why? Why is that? Okay, I give you like 3 minutes, then I will stop. Okay, 30 seconds more. Okay. Alright, so what happened to the motion of the metal coated polystyrene ball? We change the nylon thread to the copper thread. Okay, so it will become stationary. It will not move. Why is that? Okay, because there is no charge on the metal coated ball, or the charge, right, is already okay, we already charged it to it. Okay, so that's why it become, because when you, okay, let's see the diagram. There's a diagram. Yes. So this one we change it to thread, right? To the copper, right? So copper is actually, it can flow, the electric charge can flow, okay, can flow through it. So when you put the voltage here, right? So all the charge here we goes to the copper. So when it goes to the copper, of course, the charge will be flow back. Okay, so it will be, the charge will be to be will be flow to the earth, right? So there will be no charge here, because the copper can, because of the current can flows to the charge can flows to the copper thread here. So when it flows, it goes here, then it will be earth. Okay, the charge will be go to earth. Okay, so this one, let's see your answer. Yes, very good. Okay, so this one I just skip, because this one we already answered, right, for the first question just now. So I will skip this one. Okay, so this one you need to explain. All right, 4 marks. Okay, and I did explain just now. Okay, before we start, when we start early this our lesson, I already explained about what happened to the candle flame here. Okay, so you need to, this is 4 marks, mean 4 points. So they say if you want to use more than 4 points, it's okay. Mean doesn't matter, like it have to be 4 points. It can be more than that. Okay, as long the point that you said they have marks. Okay, so this one you need to say then what happened, the, let's say metal plate is has what charge, metal Q has what charge, then maybe you can using a drawing, right? You can use a diagram, right, to describe what happened. So you can draw, right? You can draw that which side we have the bigger flame, okay, and you can double, like what charge is that on the bigger flame, okay, and what uh, plate is a positive, right? I know they didn't give which part is positive and negative here, but you can just like draw it and assume that the metal plate P, let's say positive, metal plate Q is a negative. Okay, then metal plate P, okay, we attract the white charge on the flame, and metal Q will attract white charge on the flame. Okay, then what happened, right? Which side we have bigger, and why? Okay, why that side have a bigger flame? Okay. let's say you cannot, right, like you don't know how to, explain it, okay, in the full sentence, right, okay, you cannot explain it in 4 marks, just write whichever that you can, at least you can get like 1 or 2 marks, it's okay. Okay, I give you like 5 minutes, okay, to answer this one, then we see what is the mark that you can get from your explanation. Okay, for 40 second more. Right, so let's see your answer. Wow. Right, yeah, I just was the answer. All right, so let's see. What's the answer here? So what happened to the candle flame? Okay, so when the switch is on, so when already the question already said the switch is on, so you don't need to state that you need to switch on the supply, okay, the ESC supply, because you already say it's already switched on, right? So the candle flame will spreads out into two opposite directions, okay? So the spread towards the negative plate is wider, okay? So that's why I said for this one, you can draw, okay? You can use a diagram, okay? You can use a diagram. So the one that I just, let's see for this one, okay, let's say you have a metal plate here, okay? Metal plate here, then you say this a negative plate, okay, and this one is a positive plate. You can just draw the diagram here. So it should be like this one is a bigger than this one, right? Okay, so then when you put this one the positive and this one is the negative, right? Okay, so this one also you can get marks for it. At least for 1 marks, for the first mark you already can get, because you shows that the candle flame is spread out into two opposite direction. Okay, and the spread towards the negative plate is wider. So you already show in the diagram here. So the first mark you already can get, okay, from the diagram here. If you don't want to do the explanation, okay, but you need to do some, like some explanation, not like just depend on the diagram, because this is for the first mark only. Okay, and the second one is the heat ionize the air molecules. Okay, and the heat is ionize the air molecule. And the third one, the positive charge is attract to the negative plate. So this one also you already showed in the diagram. The positive charge is attract to the negative plate. Alright, so means you already have 2 marks here from the diagram. Okay, and the next one is a positive ion is a heavier. Okay, or you can see the size of the positive ion is a much bigger, right? So you can get the 4 mark here. So actually, you when from the diagram you can just get 2 marks, right? 1 mark here and one for the first one and the third point. Okay, and for first point and the third point, you already can get the mark from here. It's already seen by the diagram. And you just need to add two more, okay, and then you can get the full marks. Okay, but not all the question that you can draw. Some of it you still need to do a sentence to explain it. Okay, but for this one, it's easy for you just to do it by the drawing. Okay, so 4 marks for it. So let's see your answer. Let metal plate be positive. Okay, then the candle flame will be bigger in the metal plate Q because the negative charge is attracted therefore the candle. Okay, so this one, I 1 mark. Okay, 2 marks. Um, because in its measure, so the unit is bigger. Okay, this one, you lost 2 points because you didn't tell why the positive charge is bigger. Sorry, why does the flame, right? The flame in for the for the negative plate is bigger. I didn't inform that one. Okay, you need to say that because the size of it. Okay, the flame split two parts. The positive charge to where the 1 point here. Okay, you can get 2 points here. Okay, you lose points from the heats ionize the air molecules. Okay, right. Another one, yeah. Okay, this one I can give you one more mark because you said it's attached to the negative plate. Okay. Okay. I recommend for you, okay, to answer in the point form like this, right? In the point form like this. So I know that every point here is actually every like the dash here represent 1 point. Okay, in case because you know that the teacher's not marking just your paper, there's a lot of paper, 200 something. So by doing this you are helping them, to know that, make sure that they didn't miss any point. Okay, I know like some bio you cannot answer in the point form, right? But for physics, yes, you can answer in the point form. Okay, this way you can help the teachers, right, to know that, every this one you have a 1 point for it, so they will not miss any of your points there. Okay, and the candle flame spreads out in the two. The spread out is okay, 1 mark. The positive ion, okay, the spread is because okay, 2 marks. Okay, and this one is another one, 3 marks. Okay, when the switch is on, the divided two portion. Okay, correct. As that the portion is much larger. Okay, the hot thing ionized. Okay, the positive at the same time, the negative ion are attracted to the alright, the bigger portion bigger. Okay, so I get 4 marks. Okay, full marks. When the switch is on, the candle flame spread. Alright, 1 mark. The positive is wider and is check to the right. So this one is 2 marks. Okay, you lost mark for the size. You didn't mention why the negative plate have the bigger flame there. Okay, because of the size of the positive charge. And another one because you didn't put the heat ionized the air molecule. Okay. All right. So we can go to the next one, 3.2. Okay, 3.2 resistance. So this one is actually you already learned in Form 2, if I'm not mistaken, for series and parallel, Ohm's law, right? You already learned about Ohm's law, you do the experiments for Ohm's law. So this one is actually, it's like you just do, it's just like a revision. Okay, so like a revision. So resistance. So this one you have to compare and contrast the ohmic and non-ohmic conductor. What does it mean by ohmic conductor? What does it mean by non-ohmic conductor? Okay, and solve problem involving combination of series and parallel. Okay, so I will do a quick revision for Form 2. What is it? How does the current flows for series and also for the parallel? Okay, and define the resistivity of wire and describe the factor. Okay, the factor affecting the resistance, the diameter, the length of the wire, the type of the material for the wire. Okay, and communicate about the application of resistor in daily life and solve problem. Okay, by using the formula R is equals to rho L over A. All right, so Ohm's law. So this one actually you already learned in Form 2. What does it mean? What does mean by the Ohm's law? So the electric current, so Ohm's law said, okay, uh, the electric current flows through a conductor is a directly proportional to the potential difference. Okay, the current is directly proportional with V. Okay, across it if the temperature and other physical conditions are constant. I mean there is no increase in temperature because when the temperature increase, the resistance also will be increased. Right? So the Ohm's law said the current is directly proportional to V, okay, as long the temperature and other physical conditions are constant. Okay, and let's say if you draw a graph, okay, for let's say this is the graph, sorry, this VV, it will be directly proportional. Okay, and I believe you already done the experiment, okay, when you are Form 2. Okay, so this is the formula for the Ohm's law. That is V is equals to IR, right? Actually, it's come from here, right? So you already know V. If you want to make the equation, you have to put the constant here, right? V is equals to Ki. Then K is a constant, so we put R. Okay, we replace it as R because along the experiment, we assume we're using the same resistance. Okay, we use the same resistance. So the formula is come from here. V is equals to IR. V is the voltage. The unit is volt. Or sometimes they put it as a potential difference. V is a potential difference and the unit is volt. And also I is the current. Okay, and the unit must be ampere. And R here is the resistance. Okay, and the unit is ohm. Okay, that's the symbol. Okay, so V is equals to IR. So this is actually the triangle. Let's say if you want to find V, yeah, you can use I times R. If you want to find R, you can use V over R. If you want to find R, V over I. Okay, or you can just simply remember this formula, then you just arrange it back. Okay, and also this is the device, okay, and the symbol. Okay, device and also the symbol. Okay, so this one is the emitter. Okay, emitter. This is a symbol for voltmeter. And this is a connecting wire. Okay, sometimes they just throw it in the line like this. Okay, and this one is the resistance. Okay, and sometimes they use this one like this. Okay, this one is the rheostat. Okay, this one is the rheostat. Okay, this one is a rheostat and this is the bulb. Okay, and this is the bulb. Okay, and this is the constant wire, right? And this is the symbol for switch and this is battery. Okay, so you need to know all the symbol. So in case you know that, but this one already come up from the last year experiment for paper 3. But who knows, maybe this year again for electricity, we don't know. Okay, but you need to know all the symbol for this. Okay, and experiment 1. Okay, why do the emitters show different reading? Why do the bulbs light up with different intensity? Okay, so actually this one is to show that the current influence, right, the brightness of the bulb. So if you use the high current, okay, the bulb will be brighter. Okay, so current influence the brightness of the bulb. So the higher the potential difference, the higher the current. So you can see here the hypothesis. Remember when we are in the class, I told you, right? Some of you using this as a conclusion, right? As a conclusion for your graph. So I said cannot because this one is the hypothesis. So the hypothesis, the higher, right? The one that you should conclude when you draw the graph, okay, directly proportional, increasing linearly. Okay, only that. Okay, and this is the experiment. Okay, we do it in the lab. Okay, when we come to this chapter. Okay, so this one is actually how is the Ohm's law, the one the experiment that you did. Okay, during Form 2. Okay, during form 2, you already done this experiment. So this one is actually a revision. So this is how you set up the experiment. Okay, so your start, and remember the voltmeter always have to be parallel to the apparatus. So let's say if you want to find the voltmeter, the voltage for the constatant wire. So you need to put it parallel to it. Okay, and the ammeter should be in series. Okay, it should be in series like this. It cannot be a parallel. You see, if you put it wrongly, okay, then the voltmeter, okay, will be broken. You cannot use it anymore. So you have to make sure that your voltmeter is a parallel. So what you want to measure? If you want to measure the voltage of the constatant wire, then you put it parallel to the constatant wire. If you want to measure the dry cell, let's say later you will learn about the internal resistance. Okay, you have to connected it parallel to the dry cells. So you have to know what is the voltage that you want to measure. What material? What is the apparatus that you want to measure? If you want to measure the constatant wire, then you put it parallel to it. Okay, and it has to be ammeter, have to be series. Okay, and this is the setup. Okay, for the experiment. Okay, and you record it. So let's say this example of the reading here. Okay, and you need to find the R here. Okay, so this one I just if I just like like because you already done this experiment, right? Okay, and for this one it's actually they compact. So this one for the Ohm's conductor. Okay, Ohm's conductor means they obey the Ohm's law. Okay, means when you draw the graph, you will get directly proportional. So that is the Ohm's conductor, and they put it constatant wire. So other than constatant wire, copper also can be used. Okay, because copper also will obey the Ohm's conductor. Okay, so this is for the Ohm's conductor, and this is for the non-ohmic conductor, a filament bulb. Okay, a filament bulb, why is a non-ohmic? Because non-ohmic conductor, um, there's if you still like I'm not sure we didn't use this bulb anymore. Okay, now we're using like LED, right? So this is the filament bulb. Inside of it, they got a filament. Okay, so let's say when the current flows to it. Okay, when the current flows to it, if you notice, right, if you hold the bulb, okay, after you switch on for some time, so the bulb will become hot, right? If you touch it with your hand, it will become hot. Okay, so means there is a increase of temperature, right? While you know already the Ohm's law said to make sure that if it is obey Ohm's law or not, okay, the temperature must be constant. Okay, you cannot change the physical condition. The temperature must be constant. Then you can say that is is obey the Ohm's law. But this one, the filament bulb, okay, when you switch on for the some time, okay, there will be increase in of temperature. Means the temperature is not constant. Okay, so that's why we call it is a non-ohmic conductor. Okay, and it's a filament bulb, and we didn't use this one anymore. Usually they use it the yellow one, right? That one is a filament bulb. Okay, so now for the filament bulb, okay, you can see the reading here, right? The resistance is increased. Okay, the resistance is increased. Okay, so when you plot a graph here, okay, so there are two type of graph, V and I just fill all the graphs. Yeah. So you can see the difference of the graph, right? So this graph is a directly proportional. Okay, so it comes from the pass through the origin. Okay, and for this one, right? For this one is not, because it's not a straight line, or even though it passed through the origin, but it's not a straight line, it's not directly proportional. Okay, and the resistance is keep changing. Okay, we already learned the resistance. Okay, the graph for V against I, the gradient is actually equals to what? The gradient of the graph, this one is actually equals to resistance. Okay, but for this one, you cannot find the gradient is constant, because this one you need to do, I think, differentiation, or I don't know, this one you learn in MS, right? Okay, because the gradient it keep changing. Okay, it keep changing for all points, so the gradient is not constant. Okay, whereas this one, the gradient is constant. Okay, so this one we can say, okay, for the when you draw the graph, you can get a straight line and it pass through the origin. Okay, then this is the ohmic conductor. But for this one, R against I, okay, and this one is not the ohmic conductor because cannot get the straight line. Okay, okay. So the larger the current, the larger the potential difference. This one, the current is directly proportional. Okay, so precautions. This is for electricity. Okay, so let's say the experiment come out for the electricity. So this you the precaution that can you use. But okay, I just want to remind you, please use the one that I give you usually. Make sure your eyes is better because that one is the answer for all type of the experiment. So you don't need to remember that much. Okay. So this one, make sure the connecting wire are connected tightly, okay? And avoid parallax error. This one is also the one that I said, make sure your eyes are perpendicular to the scale reading of the voltmeter to avoid the parallax error, right? And switch off the switch if nodes are taking any reading so that the temperature. So whenever you do the experiment, okay, let's say later we do on lab, okay, while you're doing the experiment, if you're not taking any reading, please switch off. Okay, please switch off the circuit first. Okay, switch off first because if you don't switch off, okay, the first one, what happened? Because you're using a constant wire. Okay, we use a constant wire and also the connecting wire. So the connecting wire become heat. It will become heat and the temperature will be increased. So we don't want that, right? So whenever in the lab, right, when you do this experiment, please switch off. And also it's actually to like to save your battery. If you keep switch on, then your battery will be low. That's why you cannot get the correct reading because you're using your battery and also your battery also become heat also. Okay, so make sure when you do this experiment, when you don't want to take any reading or maybe you want to set it up first, right? So switch off first, right? And what is the function of the rheostat? Of course, to control the current that flows. That is the function of the resistor. Rheostat is actually it's a resistor, but the resistor that you can control the amount of the resistance. That is a resistor, okay, that is already specific amount, okay, and it's actually depending. You learn it in RBT. I'm not sure, right? The color, right? The brown. What is the doesn't mean? What is the amount of the ohm? I'm not sure you already learned that one. Okay, but the rheostat between the difference between the rheostat and the resistance. Okay, the rheostat you can control what amount of the resistance that you want. Okay, then calculate the gradient. So the gradient, I told you for the gradient must have the triangle. Okay, and the size of the triangle, so I already explained. Okay, what is the size? Okay, and the unit. Gradient must have unit. Okay, and what is the physical quantity? I already explained just now. The gradient represent the resistance. Okay, the ohmic conductor. So this is the last one before we stop. So the ohmic conductor that which obeys Ohm's law, and the shape is a straight line through origin, and the current is a directly proportional to the potential difference, and it's a fixed gradient. Means you have a fixed resistance. So as let's say 3 ohm. So along the experiment that we did, we have 3 ohm of the resistance. Okay, but for the non-ohmic conductor, it will not obey Ohm's law. Okay, and the shape of the graph is the curve shape. Okay, so whenever you want to find the gradient, you cannot find the exact gradient for it because it keeps changing the shape. Okay, so when the current increase, the potential difference increase. We cannot say directly proportional increasing linearly, no, because linearly mean is straight line. This one is not a straight line, it's a curve. So you can use like the hypothesis. When I is increased, V also increase. Okay, and the gradient will be increased. Okay, you can just simply draw the triangle to show it, right? So you see the size of the triangle increase, right? So mean I already told you the size of triangle represent gradient. So when it increase, the size of triangle increase, gradient also increase. Okay, so it means the resistance of the bulb also increase. Why? Because the temperature increase. Okay, example like the filament bulb. Okay, so I think I stop until here. So we continue on Tuesday. I think at 10 a.m. right? Okay, so I see you on Tuesday. Okay, so take care everyone. Have a happy holiday. Okay, bye. Bye, welcome.